Okay, so I'm going to go over a few things with you in regards to your Welcome Back Lab. So, Station 1, I had you set up a density lab. Um, it was yours to do as you saw fit. So, some things we wanted to come out of here was the idea of quantitative and qualitative. Qualitative were going to be your description words. So, you could describe the color, you could describe the shape, you could describe how well it floated, um, all that. Basically, you have no numbers, no measurements here. Then I wanted you to get some number-based stuff, and I saw students do all kinds of stuff. They would measure how far it floated. They would measure the mass of the can. They would write down the ounces that it was for the volume and all that. And then hopefully you remembered about water's density being 1. And so when you saw it floating well, then obviously it was less than 1. If it was right on the line with water, its density's got to be basically 1. And then if it sank or was down below the water line, its density was greater than 1. And so that's what we will pull out of Station 1. Station 2, this is a list of the equipment that I asked you to look over, to review again, to get yourself situated with what we're using in lab. Station 3 was strictly on chemical versus physical changes. So chemical changes, I just wanted you to go back over, well, how do you know the reaction occurred? So I heard some of y'all talk about the gas. Some of y'all talked about a temperature change. And most of the time we can rely on that. We have endo and exothermic. So I'll write that down there because that is a word we will be using. So we have endothermic and exothermic. Okay. Um, so it usually is a good indicator that we have a change. If we see a color change, maybe an odor being given off, but some substances do have an odor and it's not exactly a chemical change. And then if a precipitate formed, I heard some of y'all were actually um, weighing your stuff before and then weighing after. Great job with that. Physical change, I'm able to get it back to where it was. So if I have anything that deals with the states of matter, so evaporation, vaporization, condensation, that kind of language indicates that I have a physical change. Station 4 was the one that some of y'all got hung up on, going back over chromatography. So we did paper chromatography. We had water down here, and we set up our filter paper with our dots on the bottom, and then let them run up. And then hopefully you got it split enough that you can actually match up your samples with the one that I put in the folder for you to determine who the culprit was. The reason we do that is because some of your first labs you will do chromatography based labs where you're separating, but we'll actually get a little bit fancier than paper chromatography. But the concept's the same, and that's why we do it. Station 5, your numbers might vary from what I have for this picture here, but basically getting you to do the measurements, remembering how to measure, and like for the burette, that those breakdown lines represent the decimal versus your graduated cylinder versus your volumetric pipette. And then we have our two least precise measurements over here, our beaker and our volumetric flask, because we have no increments of measurement. And I heard some of y'all go back over the idea of accuracy and precision and about measuring. So nice job with that. Station 6, these equations that I have written for your assistants are not balanced. So this is just to help you. These are some examples that you could have done. I did make you do these two here. So getting back in the swing of things about how to write our formulas from our names, our states of matter, and then make sure you balance them. I did also hear people remember their 5 types of reactions. So we had synthesis, decomposition, we had single replacement, and I'm going to shorten these words here. We have double replacement, and we had combustion. Okay, so I think hopefully you remember this. A plus B yields AB, and then AB breaks down into A plus B. Single replacement, A plus BC yields AC plus B, and then AB plus CD yields AD plus BC, and then combustion is a hydrocarbon, which can be also plus oxygen yields H2O and CO2 as long as it's complete. So don't forget you do need to balance your equations. And that should be a pretty easy thing for you. I have confidence in you. Great job on your Welcome Back Lab, and live long and prosper.